Good morning. I thought I'll make a short video recording to help you guys understand how to work with the unit step function. The unit step function, if you remember, is like turning on a switch, right? At time t equal to 0, okay, the signal goes from 0 to a 1 abruptly, all right? And then it stays at a 1 essentially forever. Now the ramp function is like the integral of the unit step function. It's 0 all the way until t equals 0, and then it starts to increase at a steady rate, okay? And the slope of this function is 1, and it's denoted r of t for ramp of t, right? Now using the unit step and the ramp function, we can build other waveforms, right? I thought I'll go over a few examples and a few comments on how to think that through, all right? So let's look at a simple example. So I have a ramp function, say r of t, right? Now the slope of this function is a 1, right? Now what if I wanted the slope to be something else, right? I can increase the slope or decrease the slope by multiplying this by a suitable constant, right? So suppose I were to do, say, 2 times r of t, right? Then the slope of this will be higher, right? So this is like 2 of r of t. So now for every run, say, suppose this is, say, t equals 1, and this being t equal to 0, right? The height, okay, is going to go up to 2 units, right? And that those units could be either voltage or current or whatever, or quite frankly, we don't care what the units will be because a signal is a signal for us, right? Now, whereas for this guy, right, for t equal to 1, okay, the height is going to be 1, right? So in general, the slope is given by sort of the rise given by the time delay, right? So if this is, say, delta y and this is delta t, then the slope, okay, is delta y over delta t, okay? And that's the constant, okay? Suppose I call the slope m, right? Then this function is going to be m times r of t. All right, so this is one way to adjust the slope of the ramp function. Now, the next thing to do is to learn about how to form new waveforms using the ramp function, right? So let's just work through a simple example. Suppose I were to plot, say, r of t, right? So this is a function that goes like that, right? Now, so this waveform is r of t, right? Now suppose I take this waveform r of t and suppose I were to shift it, okay? So I have a new waveform here, okay, that is 0 all the way till this point, and it starts to rise, okay, forever, starting with this point, right? So suppose that this time is 2 here, right? And then this ramp formula is going to be r of t minus 2 because it's been shifted. So this ramp, okay, has been shifted to the right by 2 units, right? Now let's see what happens if we were to do r of t, okay, plus r of t minus 2, right? So if we were to do that, we get a new waveform, okay? And the way to plot that is to kind of watch these two guys, right? So if you go all the way from, say, minus infinity to 0, both these waveforms are 0. So this part is going to be just 0, right? And then if you look between time t equal to 0 and time t equal to 2, we only have r of t, right? So the sum is going to be just the same as r of t, right? Now at this point, okay, you have to add up these two guys, right? So if you look at the point t equal to 2, this function is still 0, right? So at the point t equal to 2, okay, the sum is still going to be equal to 2, right? And then beyond this, it's going to, increase in slope, okay? Instead of going like that, it's going to go like that, right? So that's the waveform that you're going to get if we were to add up these two waveforms. Now let's see what happens if we were to subtract these two guys, right? So what if we were to do r of t minus r of t minus 2, right? So in that case, this part stays the same, okay? And then if you look at the time t equal to 2, right, this part stays the same, okay? There's no change. But at this point, okay, when you subtract r of t, if you subtract this second waveform, okay, the shifted ramp from the first one, it starts off at the same point here, 2, because the second waveform is at 0. From then onwards, you're subtracting a constant difference, right? That constant difference is always going to be 2, right? So what that means is that the net is going to become a horizontal line that goes like that. All right? So if I want to create a waveform that, you know, starts out as a ramp and flattens out, I just need to subtract the ramp at the point at which I want it to flatten out. Okay? So now let's see if we can build on this and then maybe do another subtraction, right? So suppose I have, say, the waveform, say r of t, okay, minus r of t minus 1. Okay, let's try that, right? So this is 0, this is 1, okay? So between 0 and 1, okay, I just have the ramp r of t. At t equal to 1, the new ramp kicks in, right? And it's going to flatten it out, right? Just that's what we just learned. Now what if I were to do r of t minus r of t minus 1 minus r of t minus 2, right? So then let's see, let's plot that. So it's going to be the same till here. From 0 to 1, it's going to go up to 1, okay? And then it's going to flatten out because I'm subtracting this ramp here. And then at r of t minus 2, I'm subtracting yet another ramp. So what that means is that it's going to just basically bring this curve down, okay, to 3, but this will keep on going, right? This will keep going forever and ever. All right. Now, what if I wanted to flatten this out and make it go horizontally at this point, right? So the way to do that is to add a ramp at that point. So r of t minus r of t minus 1, okay, minus r of t minus 2 plus r of t minus 3, right? So if I add an extra ramp here, the net result is going to flatten out, right? So it's going to go like this. Okay, so it's going to, between 0 and 1, it's going to go up, and then between 1 and 2, it's going to run flat, okay, and between 2 and 3, it's going to go down, okay, and after 3, with this new ramp kicking in, okay, it's going to flatten out like that forever, okay. So this is how you work with ramps, all right. Now, what do you do with the unit steps? So let's talk about that a little bit. So if you look at the unit step, right, it's a way to give the signal an abrupt boost, right? So the unit step u of t, okay, gives you an abrupt boost at time t equal to 0. So if I were to shift this, right, so suppose I shift this to a point, say 2, right, then this is going to look like this. So the height is still going to be 1, okay, and this waveform is going to be u of t minus 2, right, because this, when shifted by 2, gives you this, right? So now, suppose I had a ramp, okay, so suppose I had a ramp r of t, and the ramp would ordinarily go like that, right? Now, what if I were to add, okay, this is 1, this is 2, what if I were to do r of t, okay, plus u of t minus 1, right? In other words, I'm going to stick in an extra step at this point, right? So let's see what happens. So the ramp starts out from 0 and goes up to a 1 till 1, but at 1, I'm throwing in an abrupt jump, right? So I'm going to immediately jump to a 2, okay? But the ramp is still continuing, so that ramp will continue like that. Okay? Now let's see what happens if I were to subtract u of t minus 1 instead, right? So I've got my So ramp r of t minus u of t minus 1, right? Let's see what happens. So I start off with 0, okay? And between 0 and 1, okay, I just have the ramp. The unit step doesn't kick in yet, right? But at t equals 1, I have an abrupt fall, okay, of 1 unit, like that. But then the ramp continues, okay? So I can continue to, get a waveform that keeps going up like that, okay? So this is one way that I can, so the unit step gives you a way to do an abrupt increase or an abrupt decrease, okay, to a waveform, all right? So to summarize again, what we have looked at is, a way to use ramps, okay, add and subtract ramps. So if you take a ramp and you add or subtract a shifted version of it, okay, you can use that technique to form a waveform, right? So suppose I want to form a waveform that looks like, say, that, right? So this 1, 2, 3, okay, and 4, right? So then I'm going to start off with a ramp r of t here, right? And then I'm going to subtract a ramp from that here, right? So I'm going to get r of t minus r of t minus 1, okay? But then I have to achieve an abrupt bump going up here, right? So I can add a unit step, okay? But the unit step kicks in at u of t minus 2, okay? And then I need to bring this down, okay? So this is a ramp that has a height of 2 but a width of 1, right? So I need to basically do a subtraction of 2 times r of t minus 3, right? So if I do that, but then I need to make it go flat here, right? So in order to do that, I need to add 2 times r of t minus 4, and then I get a waveform that becomes like that. So here are some examples. I hope you find them useful, and I hope you're able to do your homework assignments with ease after having watched this. Thank you.